Okay, dear students, let us see what is there in this question. A pure sample of iodine 131 decays into xenon with a half-life of 8 days. So this statement is a little confusing, but out of the experience I know that this half-life is not for xenon, it is for iodine, okay? So this is the half-life of iodine. Number of iodine atoms remaining divided by number of xenon atoms formed after 24 days. My dear students, this is a bit confusing, but I'm going to give you another formulation because of which the question will become very easy. I tell you, in the topic of radioactivity, the first formula is like N is equal to N naught E raised to power minus lambda T, where lambda is the decay constant we know. And in the terms of half-life, if we want to create a formula, there is a derivation for this. And here in India, we are regularly using this formula. I don't know whether this formula is given to you or not. So n by n naught is equal to half raised to power t divided by t half. Now, in this formula particularly, I'm talking about the iodine. Iodine 131, we are not considering xenon. So now what is happening is, N is the number of atoms left, number of nuclei left in the case of iodine, and N naught is the initial number of atoms with which we had started the radioactive decay. So, according to this, the number of iodine 131 left after 24 days. Now, this will be given by N naught into multiply by half raised to power. Now 24 days have been given and 8 was the half life. So it will be like this. So we all know that 8 is a 24. So this is coming out to be N naught by 8. It means only N naught by 8 nuclei for the iodine sample are left and the other have exhausted. So how many the nuclei they have disintegrated? So number of nuclei disintegrated. So this will be N naught minus N naught by 8, the number of nuclei which are still there present in the sample. So these many nuclei have been disintegrated. So obviously when they disintegrate, they produce xenon. So the number of xenon atoms formed will be equal to 7 N naught by 8. So now coming to this question, so we are now finding the ratio. So number of iodine atoms remaining, how many are remaining? N naught by 8 is remaining. And how many xenon atoms are present? They are equal to the number of iodine atoms which have disintegrated. So it will be 7 N naught by 8. So this gets cancelled. So our answer for this ratio will be B, that is 1 by 7. Okay, so this is how we do it. And according to me, this should not be atom. They should call it iodine nuclei. So that I believe is an error in the question. But anyways, we can ignore that error. Okay, dear students, so this is Professor Varun. Please subscribe to the YouTube channel. And if you're watching this video, do not forget to say hello to me on my WhatsApp. All the best. Bye.